So I'm going to be drawing from here a lot from this booklet. So if you want to take it apart in this corner, and if you have a binder, right, you can then just insert pages as you go along, right? So that is always an option, okay? So let's go over this. I normally had it as a mental math. I thought I would just add it so that way you could just kind of do this yourselves, okay? Two angles whose sum is 180 are said to be supplementary angles. Okay, supplementary angles. Two angles whose sum is 90 are said to be complementary. Okay. Vertically opposite angles are always congruent. That's the fancy word for equal, okay, or the same. And I'm going to use some of this to teach as well, right? So supplementary angles, any straight line that you observe, right? If you can observe a straight line, it measures 180 degrees. Like pick any point on this line and you measure from end to end, and it's 180, right? So if you see a line cutting through a straight line like this, we know that these two add up to 180, okay? So this is a very important concept. Sometimes it's so obvious, but students overlook that, okay? It's very helpful. Vertically opposite, like if you imagine an intersection like this, like right here you have 1, 2, 3 lines intersecting. You know that vertically opposite, right? If you follow this line and you make another one, these are vertically opposite here, right? If you follow this line and you make an angle there, these two are vertically opposite, and then these two would also be vertically opposite. So they're always equal to each other along that vertex here, or the intersection, okay? A line that intersects two or more lines is called a transversal. How many sets of corresponding angles does a set of parallel lines have? Okay, so technically this is a transversal right here, and these are my parallel lines here. Usually they should have a marking there. Some of the homework questions you just have to assume it, the ones that look parallel are indeed parallel. But how many sets of corresponding? You should have watched the videos by now, right? So if you go along this transversal, there's one pair, right? Then you have on this side, you have another pair. So 1, 2, and then this one goes with this one, 3, and then this one goes with that one, 4. So there are 4 pairs. There are always 4 pairs of corresponding angles. Okay. I want to make a note here that don't always assume that if like these two, so 2 and 6 would be considered corresponding, but they're not always equal to each other. They're not always congruent. The only time they're congruent is if you see the markings here, right? Because when you have two parallel lines, you're copying this intersection over to here. You're having two exact same intersections, okay? Think of it that way. You're cloning this one here, and you could clone more along the way, right? So now we're going to answer 6 to 12. An example of corresponding angles would be angle 1. So let's have the diagram. Angle 1 would be corresponding to which one? It'd be corresponding to 5 here. Angle 5. That's the only one it corresponds to. Okay. And then an example of alternate exterior angle would be 7. And, well, if you remember, if you watch the lesson, right, exterior is anything outside the sandwich, right? I don't know if I used sandwich on the video. It's been a while, but these are exterior, and 1 and 2 would also be exterior. Alternate means that they're on opposite sides of the transversal, right? So it would be 7 and angle 1 in this case. An example of adjacent interior angles would be 3, and that one is new. That one you don't see very often. Adjacent means that they touch, right? So 3 and 4 would be considered adjacent interior, not consecutive. These are just adjacent interior. 3 and 4. And they are supplementary, by the way, right? Because if you see, these two are along a straight line, supplementary. An example of vertically opposite angles would be 6 and 8. Okay? 6 and 8. If 6 is 25 degrees, angle 6, what's the measure of angle 2? I'm going to zoom out a little bit here. So you have to know a couple things here. First of all, if this is 25, what is angle 2 in relation to 6? It's corresponding, right? Angle 2 corresponds to angle 6. Therefore, angle 6 is equal to angle 2, which is equal to 25 as well. I'm just explaining to you how I got that, right? Angle 6 is equal to angle 2, but you could have just answered angle 6 is equal to 25. If angle 4 is 45, what's the measure of 1? So you got to go 4 and 1 are supplementary, okay? Angle 1 is going to be 180 minus 45, which is 135. Supplementary. Right. If angle 5 is 120, what's the measure of angle 4? And we know something about 5 and 4. We call them consecutive interior. And we know that if the lines are parallel, we know that they are also supplementary. Okay? Angle 5 and 4 are that's very important to me that you know the names. Consecutive interior. They are supplementary. Therefore, angle 4 is going to be 180 minus 120, which is 60 degrees. Go to page 18, you should see one of these. All right. So if you tried some of the homework questions, or I don't know if you went beyond what I had assigned, you had some questions where there were unknowns as part of your angles, right? So I need you to understand what's happening here. This essentially, this expression represents an angle. So you can put that in brackets with a degree up top. Okay, so you take this expression here, and it's going to give you the angle. If we found x, we would be able to figure out what the angle is. Okay, so what we're going to do is, first of all, focus on this fact here, that we have parallel lines, right? Okay. Lines are parallel. And that means that four things are true. Okay? If two lines are parallel, that means that corresponding angles are congruent. That means that alternate interior and alternate exterior are all congruent. So an equal sign with a squiggly line on top. And we know that consecutive interior angles add up to 180. These things, as soon as you see the parallel line symbol, you can bank on this. Okay? I'm not going to write it down every time, but I don't know how much I emphasize that on the videos. And if I repeat myself, it's just because I haven't watched the video recently. Okay? And it doesn't harm you anyway. So this is true because of this. Okay. Now let's when you have one of these, the ultimate goal is to solve for x, and then find the angle, and then solve everything else, right? I'm going to go up here, solve for x first. Okay, that's your first task here. And what do we know about these two angles? What do we call these two? If you look at the diagram, we call them corresponding, right? These are corresponding angles, and we know they're congruent, right? So we can say, we grab the angle, the first one, right? We grab the first one, and we say that that one is exactly equal to this angle here. And I will put it in brackets for now, but we don't really need the brackets. Okay. And now it's just 9x, bring the 11 over, minus 11x. I will bring all the numbers over to the other side. So 8 minus 32, like this. I bring the 32 over, it changes signs. I bring the 11 over here, it changes signs. I'm left with negative 2x is equal to negative 26. No, sorry, negative 24. And then we divide both sides by negative 2. X is equal to 12 degrees. That's important. Okay. Okay, so now that we found this, we're going to find, let's call this, let's go to our diagram, and I like to have a letter here. We're going to call this angle E, and let's call this angle here F, right? E and F, we added that to make it easier. So E, angle E is going to be 9 times 12 plus 32. And you can actually type that into your calculator, 9 times 12 plus 32, you get 140 degrees. So now you are talking angle sizes, right? You found X. Now, where did I get this from, folks? I got it from here, the expression that goes with E, right? I just plugged in the 12 into that expression and figured out what E was. F goes without saying. You can plug it in here as well. I will do that. But you still get 140, which is what we want. We knew they were congruent, right? Now we'll find the other angles. Angle A. Watch, I'm going to start my journey here. Angle A is going to be, you have to be careful here because there are many ways of justifying, but I will explain my thoughts here. A and E are vertically opposite. So you can say that angle A is going to be 140. It's vertically opposite. That's how you justify it. Okay? And we'll say 2E if you want to be specific so later you can follow. It's like, how did he come up with the 140? They are vertically opposite, and that property is always true regardless of lines being parallel or not, because it has nothing to do with parallel lines. It has to do with the intersection. Okay? And then D, you can do D first if you want, or you can do it in order. How about we do B next? Let's do that in order. If you look at, right, B and E are alternate interior angles. And we know that alternate interior angles in this case are also congruent, so it's 140 again. And we'll say it's alternate interior to angle E. That's how I'm justifying it. I'm traveling away from E to here, and I'm like, hey, these are alternate interior. So if this is 140, then this will be 140 as well. Somebody's probably thinking this right now, but Mr. Dirksen, I found A, right? You told me A is 140. Couldn't I have said that A and B are corresponding and corresponding angles are congruent? Yes, you could say that as well. So how you justify it, it doesn't matter. You'll see that there are many ways to get there. Let's do angle C. I will just use different ones, okay? C and E are consecutive interior. C is going to be 180 minus 140, which is 40 degrees. Consecutive interior to E. I'm basing everything on E here, as you can tell. I'm traveling out from E all the time. But notice this, C is right next to B. You could also just argue that these are supplementary because they are along a straight line. So B and C are supplementary. So if you went 180 minus 40, you would still get 40. And I need to find D still. Watch what I'm going to do here. I determined that C is 40. Let's travel from C to D. What are C and D? What are they called? They're called corresponding. Okay? And we know that corresponding angles are congruent in this thing. So I go look at C. C was 40, so D is also 40. Corresponds to angle C. This is just one way of justifying what I just did. And I will tell you this, I can't do all the examples, right? But this skill you've just applied here can be done in many different ways, right? I could have, and you'll see that in the example below, right? You have many ways of getting there when you start justifying. So this is the actual angle measure here, and this is the justification how I did that. Okay. Let's go and try. I will ask you to try this one here. We're not going to determine, scratch this. We're just going to find X and Y here, because it's going to be too crowded there. Find the values of X and Y for each one. So let's call this A here, and this is going to be B. So we have, it just saves you having to write these down, right? So, and this is assumed that these are parallel, okay? The lines that go sideways in this case doesn't have to always be horizontal, but they're parallel. Okay, Berlin. We're on page 18 of your booklet, okay? That handout booklet. I will just give you one hint, okay? If you go back to here, to the top, which one of these four goes with the two angles that you're given? And what is true about these two angles? Okay. So think about that for a bit. I just want you to think a little bit. Okay. So again, when you see something like this, it's really this expression here would tell me what the angle is in there. And then this expression here tells me what this angle is right there. Okay. These two are called consecutive interior angles. Right? These two like that, they're consecutive interior angles. We know that these two lines are parallel. These two lines are parallel. Therefore, we know that these two add up to 180. Okay. Supplementary. They're supplementary because of this. Okay. So you make that conclusion. You call them by name, and then you know what's true about them, given that they're parallel lines. So solving for x here would be 5x plus 26 plus, because you add them up, right? Because we're saying that if you were to add them up, we know that they are equal to 180 degrees. Okay. And really, because there's no negative sign in front of any of the brackets, you can just get rid of the brackets. There's no multiplication happening in front of them or anything. So it's just 8x, right? The x's are here, and then we combine these two, 20 plus 26 minus 46, that's negative 20, is equal to 180 degrees. You're basically combining like terms. And then 8x is equal to 180 plus 20. The 20 comes over adding. So it's 8x is equal to 200. Divide both by 8. X is equal to, that's 25 degrees. And in this case, I just ask you to find x. I'm not asking you to solve. If I asked you for the actual angle measures, you would have to go back and plug it in to figure that out. But it's just too much work right now. Okay. Now let's step it up a notch. Okay. And we're going to have to be careful with our room here. But notice this, right? When you have something like this where you have y and x mixed up, I want you to just focus on the ones that have an x in it, and the ones that have a y in it, you will do them separately. Okay? So that's important to distinguish, right? Some students try to mix them all up. It's like, hey, these are vertically opposite. You see that? This one is vertically opposite to that one. So they'll try to say, hey, 11x plus 8 is equal to 4y minus 14. But you're gonna have an issue there because you have two different variables. It doesn't work. Okay, so you match same variables in this case. These here are supplementary because these are technically adjacent interior. And these are supplementary no matter what. Like even if you were to remove everything else, we know that these are supplementary because they're along a straight line. So you don't even need to know one of those four properties up here. You don't need to. These are supplementary no matter what. So let's solve for x there, 11x plus 8 in brackets like that, plus 9x plus 32 is equal to 180. And why don't you go ahead and solve that? I'm just trying to find something here. So go ahead and try to solve that one for x and try the so I solved for x. You can look up if you're almost done. Okay. Now I'm going to solve for y. What do we know about these two? I feel like I want to add something in the notes. Yeah, Jeremiah, question? Do you have a question? Okay. Um, what I'm thinking here is to add a note because you're going to come back to this, like how did you come up with this, right? I will just say this, right? These are called adjacent interior, always equal to 180. That's what I will say, because supplementary will just not fit in, right? Because if they're along a straight line side by side like this, you know that they're going to add up to 180. So don't make them equal to each other. That's the common mistake I see. It's like, oh, it's always equal to each other. 11x is equal to this. Like, no, these two add up to 180. So the 180 needs to be there. What about the orange ones? These are called, Jeremiah, do you want to say what they're called? I'll give you your chance because you raised your hand. What are the orange ones called? Alternate exterior, you're right. And what do we know about alternate exterior angles? When the lines are parallel. They are congruent. You got it. Yes. So this one, and please pay attention, okay? They're only congruent because of these symbols. They're always called alternate exterior. That is true. But the fact that they're congruent is only the case because of this. Because later on, that's going to be tricky. Because I will ask you, how do you know these lines are parallel? A lot of students will say, oh, because of alternate exterior angles. Like, well, and so you will have to be specific, okay? Anyways, so we know that 2y plus 10 is equal to 4y minus 14. They're equal, they're congruent. This angle is the same thing as that angle. That's what you're saying here. And so I'm going to bring all the y's over to this side. And I'm going to bring all the numbers over to the other side. You do this the way you feel more comfortable, right? If you don't like negatives, you bring everything over to the other side. That's fine. You got negative 24. You divide everything by negative 2. Y is equal to 12 degrees, that is. Okay? So you solve for x, you solve for y. You didn't solve for angles. I will strongly discourage students from doing the following. Some students find out what x is, and they'll plug it into this, solve for whatever this is, and then say that, hey, these two must be equal to 180. So they'll just say 4y minus 14 plus the angle they get here is equal to 180. It won't add up. You'll get a different answer. It's not designed for you to do that. It's designed for you to like match the right pairs and then just work it out that way. Okay. We'll wait with this parallelogram for a bit. I'll come back to it later just in case I run out of time. So let's go to 19. Yeah. Page 19. So here's notation, right? 3-letter notation for angle, right? You have a 3-letter notation for angle. You need to focus on the middle, right? This is where it revolves around. So if you look at angle ABC, right? Read it the way you're seeing it. You start at A, right? Then you go B and C. So where's the angle that you're wondering about? A, B, C is connected. They're actually asking you for this. So we know that the 35 goes here. Okay. And then there's angle EAD. You kind of want to focus again on the middle, right? And then just follow it along, like read it the way it says. EAD, it's the angle formed between, right, these two legs. So that's 75 degrees up there. So you got to be comfortable with the 3-letter notation. Okay, I will say that this is also a three-letter, right? So three-letter notation applies to both of them. I know a lot of you know this already, but you got to be okay with that. This is why the three-letter notation is important. Because technically you do not have, if you just set angle D, right? Which one are you referring to? Is it this one or this one? So you can't just say let angle D in this case. You could say angle B here because that's the only angle, interior angle in question. But this one you need to, if you want to refer to this one, you go BDE to refer to that one, right? And so forth. So sometimes the three-letter notation is better. All right, find the following and explain. So you don't always have to do this in order. And in fact, I will probably go, let's see, ADE. ADE is this one right here. So we're focusing on D, right? But we have to be careful, right? ADE is this one right here. And I'm going to use a different color to write in the ones that I'm finding, okay? And I strongly encourage you to use the diagram, but then bring it over here to, why is this 35? I just went and decided, hey, I'm going to go 35. It's because I have a set of parallel lines here. They go like this. This is technically a transversal. It just happens to be the side of this triangle, right? And so we know that these two are corresponding, right? They're corresponding. So you come over here and you say that the angle measure is 35 degrees. And you say corresponds to angle B. That's what you will say. So you've justified and explained why it is that you came up with the 35, right? So I went from here to there by using corresponding, right? Corresponding. That's how you got that. CED, I'm first going to figure out which one it is, but I know it revolves around this one. CED, CED, they're asking for this one. Right now, I don't know. Okay, I don't know. Please don't make the mistake to jump between transversals, because this is a transversal and this is a transversal. You cannot jump that way. You can only jump between parallel lines. All right? So you can't say, oh, this one and this one are alternate interior. Not true, because they're not, right? These two are not between parallel lines. Okay? So you need to first figure out C here, because you know something about these two if you were to know what C is. Okay? So I will do that. So I found this first, and I found this second. Please let me know if you do that as well, which one, in which order you do them in. And C is part of a triangle. So we're mixing triangles in with angles and lines. We know that the sum of interior angles in a triangle is 180. So we go sum of triangle is equal to 180. So you can actually just do the work here. So you go 180 minus 35 minus 75. And you get 70 degrees out of that one. And then you just plug in the 70. So that would be an explanation to me. You mentioning that you're using the sum of interior angles in a triangle and that they equal to 180. So you just subtract the two angles that are given to get that third angle. Okay. Now we can go ahead and find this angle here, which is the one above. So that's my third one. What do we know about these two? I can jump, and these are consecutive interior angles, this one and this one, because they're both on the inside along a transversal that connects two parallel lines. Okay, so you're jumping. That's what I call jumping. You can jump between parallel lines using the properties, okay? So consecutive interior. So I'm going to go over here, and why not write this in? We know this is 70, right? I'm going to write it in with a red pen to tell me that I found out what that was. And I know these are supplementary. So I go over here and I say consecutive interior to angle C. We can just use one letter notation there. So I'm going to go 180 minus 70. That's 110 degrees. That would be explanation with a little bit of math there. So I'm going to put 110 here. And it does look obtuse anyways, right? So I found that this is 110. Let's do the other ones. ADB. ADB. What is that? ADB. That's a straight line. And we know that a straight line is 180 degrees straight angle is equal to 180 degrees. So that it's a straight line, so don't be fooled by that one. Nothing else. So we are combining our knowledge of parallel lines connected by transversals with the properties of triangles, right? Also with the properties of, you know that, right? These two are supplementary. We know that a straight line, right, is always equal to 180, straight angle. And we know that sum of a triangle is always 180 degrees. So these are always there for you to use, always, okay? You don't need parallel lines for that to be true. And then we're combining the parallel line, like the 4 you always need to watch out for, consecutive interior, corresponding, alternate exterior and interior, right? So we're combining all of those. These are always true. The parallel lines of 4 are only true if you see the signs, right? AED, so we found this was our 4th angle that we found. So lastly, we're going to find this one, AED. So AED, we're looking for this angle right here. And we know that this one and this one corresponds. So the 70, if you were to jump over to this one here, it corresponds. It's consecutive if you just go to the inside here, but it corresponds to the one up here, right? These are corresponding. And we know that they're congruent. So if this is 70, we know that the top here is also going to be 70. This is not drawn to scale at all, as you can tell. So 70 corresponds to angle C. And they are congruent, right? So explanation, I don't need it to be a sentence. I just need it to make sense and to see like keywords, names for the angle or the property that you're using. Okay. I think this might be the last one we will do today. We'll do the scary one, this one. Can you please, I don't know what happened there. Just connect it there. So this is going quite like it's very busy, right? This one, but you can distill it and just think about the properties that we've talked about. And this one combines, if you see it, right? You see triangles here, right? So you can always say, hey, I'm going to keep that in mind. you see vertically opposite angles here at this intersection. So hey, let's keep that in mind. That's always true. But to get you started, you most likely will need to resort to the 4. The 4 meaning alternate exterior, interior, corresponding consecutive interior. Okay, those are most likely going to be your go-to. Okay, so let's highlight this. It's like, hey, I see parallel lines. I'm pretty sure I know what's going to happen here. So this line is parallel to this line. This is what I would suggest you do. You travel, because I told you can jump, but you're jumping along the transversal. So let's travel along this transversal and then go over here. It's almost like you're making a Z. Let's see if I can make that with this highlighter. See that Z there? This is 53. And what would C be here? What do we call these two? Maybe you need to do one of these here. Right? What do we call these? Maybe I'll do this here for you quickly. Right? This one and this one, we call them alternate interior. Same with these two here. Okay? So I don't know if you see it. I hope you do. But these two are alternate interior, and that allows us to jump. Forget about everything else, like forget about this transversal for now if you can. If you can't do that, right, just focus on the transversal that I traveled along. And that's going to allow me to find C here. All right, so that's the first angle I'm going to find. Sorry. So I'm going to go angle C is equal to 53 degrees. Okay. And my explanation will be alternate interior angles are congruent. That's what you need to say there. Alternate interior angles are congruent. Okay, so we did that first. And then you can go every which way you want from there. Do I have a different highlighter? Yes, I do. Yes, I do. I knew it was going to come in handy one day. You see on this side of the parallel line, you see that if you follow that transversal, you can probably find A, right? Because they're alternate interior as well. So I'm going to kind of go here, take a sharp corner, travel across. Highlighters are probably going to be a lifesaver on this one. If you want to use highlighters, go for it. But we know that this angle and this angle they're also alternate interior, right? We know that we're jumping between parallel lines. We're allowed to do that. Okay. So second angle I'm finding. Why didn't you do that first, Mr. Dirksen? You messed everything up. Well, I do that on purpose because there isn't just one way of doing that. Okay, so A is 44. And I will just say alternate interior angles. I allow you to shorten it like that. Alternate interior angles are congruent. Okay. So now you've found these two angles already. I'm going to go ahead and fill that in. This is 53 and this is 44 here. This is only true because of the markings that they are congruent, right? So keep that in mind. What can you do now? Somebody say something on the chat or earlier, okay. We know that. I know this can be a little frustrating, okay? But look at this one. If I look at this triangle here, I can find E because I have two already, right? I have these two angles. I can easily find E. And let's do that. Angle E would be, how about we explain it here? Sum of triangle is equal to 180. So we're going to do this, 180 minus 44 minus 53. And that is equal to 83 degrees. So we put down 83 here. And I'll put down 83 there. And I have an intersection here, right? What do we call these two angles? Right next to each other? Vertically opposite. So I will do F next. Angle F is also 83. Vertically opposite angles are congruent, always. So let's go ahead and put down the 83 there. I found this, I found like everything here. Now I need to focus on D. You choose. There's a straight line here along which these two are found, or there's a straight line here, the green one, upon which these two are found. So they're both supplementary, no matter which way you go. We use the straight angle property. So I'm going to find angle D. I will explain first. Straight angle or straight line, I will use them both. So we'll go 180 minus 83 to give me 97. So I'll put the 97 here. One left, guys. One left. I'll make a mistake on purpose, right? Because I see that a lot. Oh yeah, 38 and B, they're between the two parallel lines, so they're just consecutive interior angles, right? So it's just 180 minus that to get that. No. It would have to be between a transversal and it would have to be the whole thing here if you wanted to go that way. But it's just B, right? Look at the triangle that is formed in here. And you know 2, so we're just going to find B the same way. Sum of triangle is 180. So we're going to use that property, 180 minus 38 minus 97. And that is 45 degrees. 45 it is. Done. I will say this. Sum of triangles equal to 180. Straight angle. Vertically opposite. These properties are always true. So you can always count on them to help you out. You can always count on them. Okay, let me just pause there. I'm just going to look at the homework. We have 9 minutes. Let me just prepare you a little bit. So these ones are solving for X kind of scenario, right? So you just use the same property, right? These here, for example, are alternate interior. We know that they're congruent. So 8x minus 4 is equal to 60, right? And then you solve for x that way. So just apply what you've learned and try that. It's very important for you to know. Page 4 is quite frankly very easy to do. It's just, right? We know here, these are alternate exterior. This is on page 4, so they are congruent, right? So you literally just put down 59, but what I would like you to do, step further, is y, call it, right? Alternate exterior angles are congruent, like that you practice that. That's the skill that's gonna help you out, okay? On page 5, and I know based on the video, I just peeked on it at the end. Page 5, you have more transversals. You have you have parallel lines like this, and then you have a bunch of stuff going on. So I want you to be able to figure out which one is which, okay? And sometimes the best is to just kind of ignore, get rid of a parallel line, and maybe even get rid of a transversal, and just focus on what do you see, right? If U and V are parallel in this case, what do we call 73 and the question mark, right? That'd be a corresponding angle. So you know that question mark is 73, right? Next, these ones are the ones, the heavy hitters, to be able to explain your reasoning, just like we've done today. And so this is kind of how I expect you to do it on a test, right? I'll ask you for the angle and then how did you get it? If you want to do some markings here, go for it. Highlight, do whatever you need to. That's part of your work, I would say. But just go ahead and do that, okay? Other than that, I think that is it for today.